morning, students. We were seeing unit 3 photochemistry. We have seen what is photochemistry, photochemical reaction, difference between photochemical reaction and thermal reaction, laws of photochemistry. What was photochemical reaction? A chemical reaction which takes place in presence of the visible and ultraviolet radiation. Example, photosynthesis. You have studied photosynthesis. This is what happens there. Carbon dioxide and water will react in presence of sunlight and chlorophyll to give glucose and oxygen. So that will happen only in the presence of sunlight. So photosynthesis is a process which happens in the day. It will not happen in the night. Then that branch of chemistry which deals with the study of photochemical process is what we call it as photochemistry. And photochemical reactions, when we take, we can say that they are of two types. One which occurs by absorption of light, and another one is a reaction produces light, that is emission of light. That we call it as chemiluminescence or luminescence, and which takes place by absorption of light is known as photochemical reaction. Then similar way, the normal reactions will happen by absorption of heat, that we call it as thermal reaction, and they can take place even in the absence of light. Dark reactions, for example, bursting the crackers, you can take, that we used to do in the dark only, night only. Okay, then photochemical reactions are mainly governed by three laws: Grothe-Draper law, Stark-Einstein law, and Beer-Lambert's law. Grothe-Draper law states that only those radiations which are absorbed by the reacting substance is responsible for bringing about a chemical reaction. When we supply light to a reaction mixture, some of the light will get reflected, some will be transmitted through the substance, and some will be absorbed. Only those absorbed radiations will bring about photochemical reaction. Then Stark-Einstein law, it states that each molecule taking part in a chemical reaction absorbs only one quantum or photon of light. Quantum means it is the smallest energy possible by the light. So one molecule one quantum absorb பண்ணி தான் react பண்ணுனது. Then Beer-Lambert's law, it's combination of two laws. It states that when a beam of light passes through a solution containing a light absorbing substance, the intensity of the radiation decreases exponentially with increase in the thickness and concentration of the medium. ഒരു മീഡിയത്തിലൂടെ ലൈറ്റ് പാസ് பண்ணும்போது அந்த வாட் இஸ் ட்ரான்ஸ்மிட்டட் அவுட்னு வந்து இன்டென்சிட்டி லெஸ் ஆയിരിക്കും. அது எவ்வளவு அப்சர்வ் பண்ணி அல்ல ஹவு மச் இட் இஸ் டிக்ரீஸிங், அது வந்து லெங்க்த்தினே concentration depend பண்ணும். And mathematically we can write I is equal to I0 into e raised to minus k cx, where I is the intensity of the transmitted light, I0 is the intensity of the absorbed light, k is a constant, c is concentration, x is the thickness of the medium. Then we did some numerical problem. First problem was calculate the energy associated with 1 Einstein of light with wavelength 800 nanometer and 200 angstrom. I made a mistake here, sorry. I wrote 1 nanometer is equal to 10 to the power positive 9 meters. It was wrong. 1 meter is equal to 10 to the power positive 9 nanometers. 1 nanometer is equal to 10 to the power minus 9 meter, and 1 angstrom is equal to 10 to the power minus 10 meter. But 1 meter is equal to 10 to the power 10 angstrom. Okay, this was a mistake in the last video, so kindly change it. Sorry for the mistake. Now the numerical problems we have done, 800 nanometer means 800 into 10 to the power minus 9 will come. So what value here it is for 800 nanometer, E is equal to NaHc by lambda. So 6.623 into 10 to the power 23 into 6.626 into 10 to the power minus 34 into 3 into 10 to the power 8 divided by 800 into 10 to the power minus 9. So value will be 1.497 into 10 to the power 6 joule per mole. Similarly, for 200 angstrom, this value I put it as positive in the last class. It's wrong, it's negative. So value will be 5.986 into 10 to the power 5. Okay. The second problem, calculate the energy associated per quantum or per Einstein of light with wavelength 1000 angstrom. So again, the angstrom is 10 to the power minus 10. 1 angstrom is equal to 10 to the power minus 10 meter. So when we do it, the problem here, we have to substitute 10 to the power minus 10. I asked you to calculate the value. It was numerical value. Some people have sent me. Answer was 1.988 into 10 to the power 5 joule per mole, and per Einstein it is 1.196 into 10 to the power 6 joule per mole. Thank you, Akshaya. Akshaya only made me to think it. Okay, sorry for the mistake. Rectify in your video or studies notebook and study ahead. Now today we are going to see another topic, quantum yield. Quantum yield is a quantity which is used to express the efficiency of a photochemical reaction. Efficiency means how much it is reacted. To find out that, we use the term quantum yield. And what is its definition is, it is number of molecules reacting per quantum of light absorbed. ஒரு quantum of light absorb பண்ணும்போது எவ்வளோ molecules react ஆயிருக்கு. Otherwise ஒரு ஐன்ஸ்டீன் ஆஃப் லைட் அப்சர்வ் பண்ணும்போது எவ்வளோ மோல்ஸ் ஆஃப் react ஆயிருக்கு. தட் இஸ் வாட் இஸ் குவாண்டம் yield. 100 குவாண்டா அப்சர்வ் பண்ணியால் 1000 molecules உண்டு, எவ்வளோ molecules react ஆயிருக்கு. And that we can find out by number of molecules reacting in a given time divided by number of quanta of light absorbed in the same time. Or you can use number of moles reacting in a given time divided by number of Einsteins of light absorbed in the same time. Then deviation of quantum yield. If you take like that, what is according to Stark-Einstein law is, each molecule absorb 1 quanta of light. So 100 molecule is there means, if 100 quanta of light absorbed means 100 molecules should react. But actually that is not the case. And if that is the case means quantum yield will always be unity, because number of molecules reacting in a given time will be equal to number of quanta of light absorbed in the same time. But most cases this is not true. There will be either less than 1 or more than 1. What is the reason is, when you take a photochemical reaction, according to the scientist Bornstein, it takes place by 2 steps. First step we call it as primary process, second step we call it as secondary process. So primary process is the process where absorption of light takes place. So the molecule absorbs light, it will be converted to an activated molecule. Okay, AB star. So AB light absorb பண்ணி AB star asterisk ஆகிட்டு கன்வெர்ட் ஆகும். நீ செகண்டரி ஸ்டெப்பில் தான் இந்த ஆக்டிவேட்டட் மாலிக்யூல்ஸ் ஐதர் ப்ராடக்ட் ஆகிட்டு கன்வெர்ட் ஆகும், இல்லை இட் கேன் ரியாக்ட் வித் சம் அதர் ஸ்பீஷியஸ், இல்லை இட் கேன் டீஆக்டிவேட் பேக் டு த ரியாக்டட். செவரல் ப்ராசஸ் இட் வில் ஹேப்பன். ஸோ that is the step which determines the quantum yield. If suppose if AB asterisk is converted to the product as directly, it will result in quantum yield 1. But if deactivate back means what happen, 10 molecules absorb பண்ணும்போது maybe 2 only will be product ஆகிட்டு convert ஆகும், 8 வந்து it will be coming back to the reactant. In some cases that will initiate the reaction, more products will also be formed. Okay, so one is reaction with quantum yield unity. There the activated molecule instantaneously decompose into the product without entering into the secondary process. So example, Cl2 plus O2 giving Cl2O2, H2 plus O2 giving H2O2, H2S giving sulfur and hydrogen gas, C6H14 that is hexane and bromine reacting to give bromohexane and HBr. They are all activated complex will be converted to the product. There are processes where the quantum yield is less than unity. What type of molecules it happened is, activated molecules get deactivated to certain extent by collision in secondary process. AB asterisk വന്ന് പ്രോഡക്റ്റ് ആയിട്ട് കൺവേർട്ട് ആകാണ്ട് ബാലൻസ് AB ആയിട്ട് കൺവേർട്ട് ആകും. സോ ദാറ്റ് ഈസ് വൈ its quantum yield will be less. So 10 molecules 10 quanta absorb panniyal, maybe 2 will be converted to the product, remaining 8 will be converting to the reactant, so that will not become product. So example, NH3 converting to N2H2, H2Br2 converting to 2HBr, acetic acid converting to methane and carbon dioxide, acetone converting to ethane and carbon monoxide. For this 0.2, 0.01, 0.5 and 0.3 are the quantum yield. The next case is where the quantum yield is greater than 1. In this, what happened is the activated complex is a free radical, so that will initiate and it reacts in a lot of steps or secondary steps. So as a result, absorption of one quanta of light will produce more than one product. For example, oxygen converting to oxone, HI converting to H2 and I2, NO2 converting to NO and O2, HClO converting to HCl and O2. This is 2, 2, 2, this is 4. Okay. Next case is where the quantum yield is very high. In some cases, a series of secondary processes involving several thousands of molecules may take place. This leads to a chain reaction. In that case, quantum yield will be very high, 10 to the power 3 to 10 to the power 4. For example, CO and Cl2 giving CO, Cl2 10 to the power 3, H2 and Cl2 giving 2HCl, that is 10 to the power 3 to 10 to the power 4. So that type will have high quantum yield. So quantum yield is a process where we find the efficiency of the reaction and it can have value 1, less than 1, greater than 1. Okay, thank you.